This is a free body diagram. Free body diagrams show which directions forces act on an object. So we're going to use this to explain Newton's first law. Currently, in this particular picture, we can see that driving force and air resistance are balanced, so there's no overall horizontal force. And contact force, which is the ground that pushes the car up, and weight, which pulls the car down, are also balanced, so there's no overall vertical force. So right now this car has got no overall force. What does that mean? So Newton's first law says that if an object has no overall force, so all the arrows are balanced and there's no overall force, there will be no change to the object. So if the object is stopped, it will remain stopped, and if it's moving, it'll keep moving at the same speed. But if the forces were unbalanced, so for example, imagine this one, instead of saying 2,500, it said 3,000 newtons. So right now, we would say that there is an overall force in this direction by 500, because the forward is 3,000, the opposite is 2,500, subtract them, that leaves you with 500 going this direction. So right now, there would be an overall force. So if there is an overall force, they're not balanced, there are 5 things that can happen: starting to move, speeding up, changing direction, slowing down, or stopping. Any of those 5 can happen. They're not all going to happen at the same time, but potentially any of those can happen depending on the diagram. All of these are known as accelerations. Slowing down is a negative acceleration, or you can just call it deceleration. Now, scale drawings. So, for example, in a scale drawing, they'll say so a car has a driving force of 40 newtons north, and wind blows it 30 newtons to the east. What is the overall force? And they want you to draw this as horizontal and vertical components. So the best way to do that is you're going to start off with the car. So here's your car. We're going to draw north. We're going to draw each arrow at a time. So first, from here, we're going to go up north by 40. And then we're going to go right by 30. Now, the way you can do that is you have to set yourself a scale. So for example, you're going to say, okay, 1 centimeter is going to be equal to 10 newtons. So that's the scale. Now you can make up your own scale, but for example, in this one, if 1 centimeter equals 10 newtons, then I'm going, for 40 newtons, I need to draw 4 centimeters. So my first line is going to be 4 centimeters long from here to here. Then 30 newtons east. So we're going to go from here east. So it's going to be this direction. Again, 30 newtons, that's going to be 3 centimeters. So then I'm going to draw 3 centimeters, a line from here going this way. Once I've done that, to find the overall, you put a point on your starting point, and you find your finishing point, and you draw a line that connects them. Once you've done that, you're going to use your ruler to measure the size of this line. So for example, let's say that this line was 5.5 centimeters. That means that value is going to be equal to, according to our scale, 55 newtons, because we're just going to times it by 10, because 1 centimeter is 10 newtons. Now, equilibrium means when there's no overall force. So there are 2 examples of equilibrium. In this example, you can see that all the arrows are going from tip to tail. Here, there's no overall force. And also in this one arrow is equal to 2 other arrows. So imagine that's 10 and 10, and this was 20. So overall, 20 going this way and 20 going that way. So again, there's no overall force in this scenario. So an object that has no overall force, we can say is an equilibrium.
Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at examqa.com, where I will personally be there to help answer your questions. Mohammed signing out. Hey guys, If that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at examqa.com, where I will personally be there to help answer your questions. Mohammed signing out.